Now we're going to look at the square root test for determining if a number is prime. So, with the sieve of Eratosthenes that we worked in, when we circled the prime number 2, the very first number we crossed off was 4. When we circled the prime number 3, the very first multiple that we crossed off was 9. When we circled 5, the first number we crossed off was 25. When we circled 7, the first number we came to that hadn't been crossed off was 49. So there was this squaring thing that happened. And that's a process that we can use, like that idea, to help us figure out if a big number that's maybe not in the list that you have from your sieve, we can find out if that number is prime or not. Like 1,117. If we wanted to know if that was prime, we can use this little test. So the theorem says this, and remember, theorems in math are things that are already proven to be true. If n is a whole number greater than 1, so n is the number we're trying to figure out if it's prime or composite, and if it's not divisible by any prime p, where p squared is less than or equal to your number n, then n will be a prime number. Okay, so I have to know if the prime number squared is less than my number. That seems complicated. There's got to be a better way to say this. An alternative way to say this statement, p squared less than or equal to n. What if we solved it for p? To get this down to p, we would have to square root the left side. If I square root the left side, I get p. But in math, whatever you do to one side, you have to do to the other. So if I'm going to square root the left side, I have to also square root the right side. So this is an easier way to think about this. And this is the test that we're going to use. So I tried to translate it to English, from math to English for you here. To determine if a number n is prime, you're going to list all of the prime numbers less than the square root of n. That's where the square root is coming in. Pick all the primes less than or equal to the square root of your number. Test those primes, just those primes. So instead of testing all of the numbers less than your number, we're narrowing it down and just making you test the primes. This is a huge shortcut. So we're reducing an infinite amount of numbers down to just the prime numbers less than or equal to the square root of n. If none of those prime numbers divide into your number, then you have found yourself a prime number. So let me show you. I think it'll make more sense like in practice once you see this with some actual examples. Okay, so we're testing these prime numbers less than the square root of n. All right, so it says use the square root test to determine if the following numbers are prime. And so this is the test that you guys want to learn. So is the number 103 prime? Okay, the point is not to look at the sieve with all the prime numbers and just answer yes or no. So what I'll do is I'll always give you a hint. I'll tell you what the square root of your number is. So the square root is like 10.1. So what we have to do is we have to test all primes less than 10.1. I'm just going to go one decimal place because all the prime numbers are whole. So I need to test all of the primes that are less than 10.1. So let's think about this. What are the prime numbers less than 10? Essentially, there's 2 and 3 and 5 and 7. A lot of times students like to add 9 because you start thinking about odd numbers. But y'all remember 9 is not prime. So you just have to test the prime numbers. And you can use the divisibility rules to test them. That's the really nice part. So if I want to know, does 2 divide 103? Well, 103 is odd, so 2 doesn't divide it. Does 3 divide 103? Well, I don't know. Let's add up the digits. 3 plus 1 is 4. Does 3 divide 4? No. How about 5? Does 5 divide 103? How do you tell? You look at the last digit. Is it a 5 or a 0? No. So 5 does not divide it. Now, we didn't talk about the divisibility rule for 7. There is one, and I think it's said in your notes. It's in the book if you want to look it up, but I don't ever test on it. So for this one, we can just break down and use a calculator. 103, let's try to divide it by 7. No, it doesn't divide it. Since all of these were a no, that means 103 is prime. And we only had to test 4 numbers. We didn't have to test all of the numbers less than 10, just the prime numbers less than 10.1. And since all of these were a no, we know that 103 is prime. Let's try another one. 507. It's a big odd number. A lot of times big odd numbers are assumed to be prime, but maybe it's not prime. So we start with the square root. The square root of 507 is about 22 and a half. Okay, just about 22 and a half. So we are going to test all primes less than 22.5. All the primes less than that number. So let's see, we've got 2, 3, 5, 7, not 9, 11, 13, 15 is not prime, 17, 19, move my paper up here. The next prime number would be, I think, 23. So we don't need to go that high. We've got all the primes that are less than 22.5. And then we're just going to start going through the list and see if they divide or not. So does 2 divide 507? No, that's odd. Does 3 divide 507? Well, let's look at the sum of the digits. 7 plus 5 is 12. Oh, 3 actually divides 507. Which means, since 3 divides into 507, 507 can't be prime. There's no way. So I could stop right here. At least I've shown you which numbers I'm going to test. But this one's going to be composite. But for the sake of finishing this out, does 5 divide 507? No. I will tell you 7, if you use a calculator, 7 does not divide 507. We also didn't learn the rule for 11, but 11 does not divide 507. But 13 does. If you tried, like some of these bigger ones you could try with a calculator because we didn't use a rule for those. 13 actually does divide 507. 17 and 19, it turns out they do not. So, you know, your divisibility rules kind of run out when you get to 5. So you can use a calculator for the other ones. But because those two divide into 507, that means 507 is composite. Or like they'll say, is it prime? You'll say, no, it's not prime. It's actually a composite number. So that is the square root test that you can use to figure out if a number is prime.